All right, pre-calculus, welcome back. We just finished our do now and the first objective of material for this, our Module 1, Lesson 5. The second part involves doing complex arithmetic, so addition, subtraction, and different types of multiplication with complex numbers. And down here on your note sheet, there are the 4 types of operations we're going to be asked to do. As we go through these, they should feel a lot like operations we've done before. We'll kind of note that as we go through. So we'll start with scalar multiplication. First, we may not be familiar with the term scalar. You may have seen it in a physics class. Basically, scalar just means a number. It's just a quantity. Here, we're talking about a real number. It basically just means we're talking about multiplying a complex number by just a real number. So I'm going to highlight this, the real number here. Here it's 3. And our complex number is all that inside there. It has both a real and imaginary part, but we're multiplying that whole number by one single scalar or real number. So if I multiply this, we're just going to have to distribute it. We need to multiply both the real part and the imaginary part by 3. So let me simplify that. 3 times negative 8 is negative 24, I believe. And 3 times positive 10i is positive 30i. So again, I'm going to just split up and say, like, there's our resulting real part in yellow, and there is our resulting complex or imaginary part in orange. Scalar multiplication is really just making sure we distribute our number throughout. So here's one for us to practice again. Let w equal negative 2 plus I. Compute negative 3 times w. It being written next to it means it's times. And this is then plot both, and this is a typo, both w and negative 3w in the complex plane. So whenever I'm doing these computations, I'm using this language, this problem setup, because it looks a lot like the test questions that we're going to be using in this curriculum. It also gets us used to plugging stuff in. So compute negative 3w, I'm going to start by just writing negative 3 times something. Again, whenever I plug stuff in, I love to leave a blank with parentheses like this, so that whatever I plug in, I don't mix up the signs. It's kept separate at first. So I'm now going to plug in w, which is negative 2 plus I, into my blank. Negative 2 plus I. So I started by writing out the expression with a blank, and then I plugged in my number. Now we're just doing distribution like we did in the first example. Negative 3 times negative 2 is positive 6. Negative is positive. And then negative 3 and I is negative 3i. And again, highlight our real and imaginary parts so that we recognize this is a complex number. Scalar multiplication, pretty straightforward. Oh, we forgot to plot. Let's do that. Again, in this class, I'm happy with just sketches, especially initially. So that's a really quick little axis. I'm plotting, this is plot both the w. So w is negative 2i, so I'm going to go 1, 2, positive 1i. So that would be my w right there. And then I'm going to plot negative 3w, which is 6 minus 3i. So 1, 2, 3, 4, 5, 6. Oops, I counted 1, 2, 3, 4, 5, 6 minus 3i. 1, 2, 3. So maybe right about there. Negative 3w. So the idea is just to get a basic picture of where these two would be in our plane, and also practicing plotting. Scalar multiplication, all set. Complex multiplication, this is has a couple more steps, but basically it's still the same as what we had done in algebra class. So we have two things that basically look like binomials. We're just going to have to distribute each part to each of the other parts. So in this case, we have 2 times 4 is 8. 2 times negative 5i is negative 10i. 7i times 4 is positive 28i. And then 7i times negative 5i is a negative, positive, so it's negative. 7 times 5 is 35. And then I times I is I squared. So I like to do the sign first, and then the numbers, and then any symbols that are after, just to make sure I keep it straight. Can simplify just like with binomials. We're going to combine our like terms, so I'm going to highlight our two imaginary parts right now. Those both have i's. They are like terms. They're both imaginary, so they can be combined. So 8 These are going to combine to negative 10, positive 28. So that sounds like it's going to be a positive 18i. And then we still have this stuff over here. Now remember from our key fact yesterday and from our do now that I squared is equal to negative 1. So whenever we see an I squared in our expressions, we can simplify it by rewriting it as a negative 1 or substituting a negative 1. So I'm going to do that here. Again, anytime I substitute something, I just open parentheses because I know I'm going to replace it. It helps keep our sign straight. I'm going to put in a negative 1 where the I squared was. So now we can go a little bit further, simplifying. 8 plus 18i, and then this whole bit over here, 8 plus 18i, a negative 35 times a negative 1. Well, that's actually just a positive 35. So overall, we can simplify. Now we have two real parts. We can simplify this to 8 plus 35 is 43 plus 18i. So when we multiply complex numbers, we should gig out another complex number. The only extra step is that we can simplify our I squared to be negative 1. Nice. So let's do this next one pretty quickly. It says compute z1 times z2. It defines z1 and z2 here. I'm going to highlight them in different colors so that we can see where I plug them in. Every time I plug something into expression, I just open up parentheses where I expect stuff to be. This is going to be my z1. This is going to be my z2. Highlight where they go. 2 minus I and 2 plus I. So these two numbers, they happen to be conjugates. We'll talk about that later. Let's see what happens when they multiply them. 2 times 2, 2 times positive I. We get 4 plus 2i. And then I got to do the others pairs. I times 2, negative I times positive 2. So that's negative 2i. And a negative and a positive is a negative. I times I squared. Done that so far. Match up our terms. These two can combine. They're both I terms, both imaginary. 4 and a positive 2i and a negative 2i, they're actually going to combine to 0. So we can just ignore that. It's like a 0. And then lastly, I just have to plug in our negative 1 for I squared here. So I'm going to go 4 minus, again, open the parentheses, negative 1. 4 minus a negative 1, well, that's the same as 4 plus 1, which is just 5. So in this case, our complex multiplication ended up just giving us only the real part. The process is still the same. All right? Scalar multiplication, complex multiplication, good to go. Let's move on to addition and subtraction. So these are still similar skills to what we've seen before with binomials in algebra class. I like to just kind of group our like terms. We have a negative 10, we have a negative 6, and they're being added up. So negative 10 plus negative 6, that's just going to give me a negative 16. Then we have a negative 3i and a positive 6i, and they're being added up. So negative 3 plus 6 should be positive 3i. So just matching up our terms, combining like ones. For another example, here it's asking us to find the sum of these. So again, I'm just going to open parentheses so that I don't mess up my signs. 2 plus I, and then b here is just negative 3. Let's see where I got these numbers. B is negative 3. Well, all we have to do is combine our like terms, and the like terms here are just the real parts. There's a real 2, there's a real negative 3. We'll combine those. 2 minus 3 is negative 1, and there's nothing to combine the I with, so it just stays plus I. Negative 1 plus I would be A plus B. Subtraction, also similar. Here, though, we just have to be careful with our negative sign. So what I like to do personally is to distribute my negative first. I like to treat this as a negative 1, distribute it to each of my terms so that I don't forget about it, and then I'm just adding after that. So if I do that, I'm going to have 9 minus 6i. And then distributing my negative, I get a positive 3. And distributing negative again, I get a positive 10i. Now I can combine my real terms with my imaginary terms separately, and I get 12 real part and plus 4i imaginary part. Nice and easy. The only difference from addition is we have to make sure to be very careful with that negative sign. Let's do this again. A minus b, again, the parentheses are super important in making sure we keep our signs straight. Negative 2 plus 4i, and then b is 3 minus 2i. Again, I'm going to distribute the negative. There's other ways to do this. I just like to do it this way so that it's done and out of the way. Negative 2 plus 4i, and then that negative 1 and positive 3 are going to make a negative 3. And then the negative 1 and the negative 2i are going to make a positive 2i. Combine like terms. I'm going to notate it a different way. Those. Negative 2, negative 3 makes a negative 5. And then 4 and 2 make a positive 6i. So there, we've done each of the operations we need to today. Scalar multiplication, complex multiplication, addition, and subtraction. On the back side of this handout, there's even another set of worked out examples. Here we use two numbers in particular. Z1 is equal to 1 plus 3i, and Z2 equal to 2 plus 4i. And then we just showed an example of addition here, an example of subtraction here, scalar multiplication with a negative here, and then complex multiplication down here. Scalar multiplication was up there. So this is another reference for you to use as you're practicing, as you're reviewing, whenever. Make sure you put this handout in your binder with lesson 5 so that when you go back, you'll have reference. In the next part, we are going to, I'm going to ask, so before we leave this section, I'm going to ask you to try out questions 4 through 7. This is just asking us to do each of the operations, plus, minus, scalar multiply, complex multiply, and then plot all the results as you go. That sort of sums up all our skills for today. In the next video, we'll review these answers, and then you can just come in and take your exit ticket.